Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to our second lesson on the graphs of polynomial functions. Last time we learned how to graph a cubic function. Today we will learn more about the graphs of polynomial functions. We will also learn to calculate the x and y intercepts of a quadratic along with its vertex. Are you ready, students? Let us begin. We will start with an activity. Look at these three graphed functions. Which of these are polynomials? Why?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. The first graph has a sharp corner at the origin point. Polynomials always have smooth curves, not sharp ones. Therefore, graph A is not a polynomial. Graph B has smooth curves. However, there is a gap in the line in the upper left quadrant. polynomial functions are continuous. So, the line that they describe is never broken. Therefore, graph B is not a polynomial. Graph C has many turning points extending into all 4 quadrants. It is an unbroken line with no sharp corners. Therefore, graph C is a polynomial. Was that your answer? Good work, students. Note that the range of the function in graph C is the set of real numbers. Now, let us learn how to determine the x and y intercepts of a function. Observe this quadratic function. F of x equals x squared plus x minus 6. If we factor this polynomial, we find that it can be expressed as the product of x minus 2 and x plus 3. Therefore, the graph of f has 2 intercepts, 2 and negative 3. Next, f of 0 equals negative 6. So, the graph of f has its y-intercept at negative 6. We can calculate the vertex of the parabola by determining the midpoint between the two x-intercepts, which is negative 0.5. If we take x to be negative 0.5, then y equals negative 6.25. Therefore, the vertex is at negative 0.5, negative 6.25. This is the minimum range of the graph of f. The range of f can be written as y equals the value of y greater than or equal to negative 6.25. Having plotted these 3 points, we may draw our function. Try this for yourself, students. Here are 2 quadratic equations. Calculate the x and y intercepts for each along with their vertices, and use your results to plot each curve. Go ahead, students.
Students, let's get ready. Begin. Thumbs up. Let's get back to our lesson.
Hello again. Let us check our results together. The first quadratic is f of x equals x squared minus 3x minus 4. This can be factored as the product of x minus 4 and x plus 1. Therefore, the graph of f has x-intercepts at 4 and negative 1. F of 0 equals negative 4. So, the y-intercept is at negative 4. The midpoint between the two x-intercepts is 1.5. F of 1.5 equals negative 6.25. Therefore, the vertex of the parabola is at 1.5, negative 6.25. Here is the graph of the first function. The second quadratic is g of x equals 2x squared plus 11x plus 5. This can be factored as the product of x plus 5 and 2x plus 1. Therefore, the graph of g has x-intercepts at negative 5 and negative 0.5. G of 0 equals 5. So, the y-intercept is at 5. The midpoint between the two x-intercepts is negative 2.75. G of negative 2.75 equals negative 10.125. Therefore, the vertex of the parabola is at negative 2.75 and negative 10.125. Here is the graph of the second function. Did you get the same answer, students? If so, you have done a great job. Notice that each of the quadratic graphs that we have studied today have opened upwards. This is because the leading coefficient of each polynomial has been positive. This table summarizes the different graphs that are created depending on the value of the leading coefficient and the value of the exponent. If the leading coefficient is positive and the exponent is even, the graph opens up to the right and up to the left as seen here. If the leading coefficient is positive and the exponent is odd, the graph opens down to the left and up to the right, as seen here. If the leading coefficient is negative and the exponent is even, the graph opens down to the left and down to the right, as seen here. Finally, if the leading coefficient is negative and the exponent is odd, the graph opens up to the left and down to the right, as seen here. For example, consider this function. When we multiply the terms, the expression reads as f of x equals negative x cubed minus x squared plus 2x. Based on this, we can predict the approximate shape of the graph. The leading coefficient is negative, and the exponent is odd. So, the graph moves up to the left and down to the right. Then, the curve crosses the x-axis at x equals 0, 1, and -2. So, the graph looks like it is shown here. You can see the same principle illustrated in this equation, students. G of x equals x plus 1 squared times x minus 2 squared, or x to the power of 4 minus 2x cubed minus 3x squared plus 4x plus 4. Here is the graph of this function. Once again, the shape is predictable because of the properties of the leading coefficient and its degree. Be sure to note these properties of graphs, students. They will be very useful as we continue to learn about polynomial functions. That is all for today. We have learned about some of the properties of polynomial graphs. Until next lesson, thank you, teacher. Thank you, students.